Good day, grade 12 learners. Welcome to today's physical sciences lesson. Today we'll be tackling revision as we prepare for our preliminary exam. My name is Bongani Mabuya. This lesson is brought to you by the Northern Cape Department of Education in collaboration with Pagama Research and Development. We are going to tackle paper 1 today. We are going to look at the content that will be assessed on paper 1. The paper that you are going to write, it will be out of 1/5. And you will be expected to write it in 3 hours. Physics, because it is what we are going to deal with. It is a continuation of what we've been doing from grade 10 and grade 11. You can see that there are other topics that you did in grade 10 that will be fully examined in your preliminary exam. Some topics that you did in grade 11, they will be fully examined in your preparatory exam. So some of the topics that we can expect on our preliminary physics paper, it is Newton's laws that we have done in grade 11. It is electrostatics that you have done from grade 10 and you did them again in grade 11 as we were dealing with Coulomb's law and electric field at a point. Electric circuits is also an examinable topic. You did it from grade 10. An introduction of EMF, it is from grade 10. Then grade 11, you also performed complex calculations on power and the cost of energy. Grade 12, again, you had to do complex calculations of EMF and internal resistance. So these are the topics that emanate from what you've been doing from previous grades, grade 10, grade 11, because we are saying that physical sciences, it is an FET subject. It is not a grade 12 subject, but we start to pass grade 12 from grade 10. We start to do well in grade 12 from grade 10. Now, let's look at the action verbs that are commonly used in the question paper. It is important that all the time, as well as educators, we must have what we call a diagnostic report. Because a diagnostic report, it tells us about the performance of this content per topic, how learners respond to questions. And this informs the type of intervention that we can make to ensure that we improve learner attainment. So, some of the words that learners can expect from the exam is the word explain. You know, when you explain, it is no longer on level 1, it is a level 2. Learners, they must explain. Learners should be able to discuss. Learners should be able to describe, justify, analyze, apply, elaborate, evaluate, differentiate, distinguish, and compare. So these are the words that learners should familiarize themselves with. And most of the time, when the examiner says discuss, you'll see the mark allocation. It is 2 marks or 3 marks or 4 marks. Differentiate, it is 2 marks or 3 marks, where you show us what makes these concepts to be different from each other. You distinguish their properties. When we compare, we look at their similarities, we look at their differences, and you look at the mark allocation from there. It is 2 marks, it is 3 marks. And some words that are mostly linked to level 1 questions is this one, like state, name, give, mention, quote, provide, outline. You can see from there that this is where then we are saying that these are the low-hanging fruit questions, and it is easy for us to detect them because of these action verbs. When they say state, you just recall. When they say define, you just recall. When they say list, You just look at the information. When they say name, you must remember. So it is important as well, before we can look at the structure of the exam, we must look at these action verbs. We must look at these commanding words, because those are the ones that structure the level of difficulty and the cognitive demand of the question. So we are saying that the mark allocation for verbs that do not require splitting of ticks, if it's 2 marks or 3 marks, will depend on the nature of the question. This means that 2 marks will not always be awarded for each fact. Sometimes you can have 2 marks for 1 fact. Sometimes you can have 2 marks for 2 concepts. If, for an example, the question requires 1 word, then 1 mark will be awarded. However, if the question requires the candidate to apply knowledge to use the principle, then 2 marks will be awarded. And these 2 marks is either the learner is given 2 marks, all of it, or will have a split mark to say you've introduced the concept and we're able to apply the concept. 1 mark, 1 mark. Now, let's look at the structure of our exam. So we are going to write a paper out of 150 for 3 hours. You must prepare yourself. Physics paper 1, 150, 3 hours. Now, the paper is structured in this format. You are going to have question 1. Question 1, it is the multiple choice question. How many multiple choice questions are you going to find there? 10. So you are going to find 10 multiple choice questions out of 20. Then from question 2, we are going to have Newton's laws. Question 3, vertical projectile motion. Question 4, momentum. Question 5, work, energy and power. Question 6, Doppler effect. Question 7, electrostatics. Question 8, electric circuits. Question 9, electrodynamics. Question 10, photoelectric effect. So all of these questions from question 2 to question 10, we say these are structured questions, of which from it you are going to find variety of questions, a definition, a calculation, an explanation, or sometimes you have to tabulate the differences or critically analyze, critically discuss. Now, we are saying that from question 2 to question 10, the total mark will be 130. So all of those questions from question 2 to question 10 will be out of 130. So this is a general structure of physics. So this is what you can expect for your preliminary exam. Question 1, 10 multiple choice questions. How many are they? 10. How many marks? 20. Meaning that each question or each multiple choice question caters 2 marks. So the importance of multiple choice is that we must make sure that we answer all the multiple choice questions, because each question caters 2 marks, and 2 times 10 will give you 20. Then the total will be 150, as I have alluded to you. You will write this paper for the duration of 3 hours. Let's look at the topics. Now we look at these topics according to their knowledge areas for paper 1. So we'll look at mechanics, which will be 65 marks, an estimation mark allocation of 65. What we find under mechanics is your question 2, Newton's laws. It is your question 3, vertical projectile motion. It is your question 4, momentum. It is your question 5, work, energy and power. So these are the topics that you must expect from mechanics. We are saying on the paper, they will account to an estimated mark of 65 marks. Now, we come to another knowledge area, which is wave, sound, and light. The estimated marks there, it is 15. There's only one question that you'll find from there. It is Doppler effect. And Doppler effect can be 9 marks, can be 12 marks, but maximum it will be 15, not more than that. Another knowledge area, it is matter and material. It is the last topic. Question 10, photoelectric effect. The mark allocation, it is estimated at 15 marks. Then, another knowledge area, it is electricity and magnetism. Estimated mark allocation, it is 55 marks. So you can see that it contributes a lot of marks. And this is question 7, 8, 9. Only 3 questions can give you up to 55 marks. So under electricity and magnetism, what is it that we find there? Electrostatics. We find electric circuits out of 22. We find electrodynamics with 10, 11, 12 marks. So these are the topics that we are going to find on our question paper. Now, I want us to look at the multiple choice question. Already I have alluded to you that it is paramount important that we make sure that we respond to all multiple choice questions. Because if we can do well in multiple choice, already we can get something close to 20 marks, which is important. It is a serious booster. It is a confidence booster. So let's make sure, no matter how difficult a multiple choice question is, let's respond to it. Choose a letter. And don't make us to guess, because some of you write 1.1 C/D. You are telling us that we must guess. The rule that the first answer that we see is the one that will mark, it is no longer applicable. If you make us to guess, we'll mark you wrong. So make sure that you write or you respond effectively and in a corrective manner on multiple choice. So when we speak about a multiple choice question, you will be given a statement. And we are saying the scenario that you are given, like for instance 1.1, it will be a scenario that is linked to Newton's law. So when you look at that question 1.1, because you'll be given a scenario and 4 possible answers, and yours it is to choose the correct letter. So how do we make sure that we get the correct answer? Because this revision, it is meant to make sure that we give you the confidence, we give you the strategy to perform better for your preliminary exam and for your final exam. So the first thing that we need to do when we deal with the multiple choice, let's read and understand the scenario. Read and understand the question. And then from there, you underline the key words. And the key words, they are telling you that 1.1, we are dealing with Newton's laws. Then you're like, okay, so it means I have to use the knowledge that I have about Newton's laws. So let's make sure that we underline the keywords. What do they want from this question? Are they speaking about forces? Are they speaking about the laws? Or are they speaking about the calculation itself? So it is important to read and understand. And then from there, what do? We underline the important concepts or phrases. Then from there, pay attention to the words that have been capitalized, to the words that have been made bold, because they tend to be the drivers of that question. So pay attention to such concepts because they tend to be important. Like for instance, they'll say that at constant velocity. So when you see constant velocity written in bold, constant velocity, then something must come to your mind already to say, why are they indicating this in bold? They are telling you that acceleration is equals to 0 meters per second squared. So it is important as well, as we read the scenario, we look at the emphasis, we look at the words that have been capitalized, the words that have been made bold. Then we decide, what does the question want? It wants us to recall information. It wants us to perform a calculation. So you decide, because you have read the statement, you understand the statement, you have underlined the keywords. Now the keywords, they are telling you that here we must perform a calculation, or here we must refer to a definition. And then from there, once you have read and understood the statement, you look at your 4 possible answers, A, B, C, D. What do we do then? The first thing that you do, a multiple choice is structured in such a manner that out of the 4 options that you are given, 2, they are obviously wrong. And the other one is a serious distractor, and the other one is more correct. So for you to eliminate, or for you to reach your answer very fast, make sure that you eliminate the answers that are obviously incorrect. And there will be 2. And then from there, you choose the most correct answer out of your 2 left options. And we are saying that give yourself ample time to respond to the multiple choice. You have a choice. It's either you start with the multiple choice or you end with the multiple choice. But make sure that you give yourself enough time to deal with the multiple choice. Now, I want us to look at a multiple choice question. But before we can get to that, let's look at the structure of our question paper. Question 1, it's multiple choice. Question 2, it is Newton's laws. What is it that we must know about the Newton's laws? It is, number 1, the expected definitions that you can come across. There are 5 definitions. As you prepare for your preparatory exam and for your final exam, you must know there are 5 definitions that can only give you 2 marks in Newton's laws. One of the 5 definitions, it will come as it is. It's either the examiner will assess you on normal force, you can write that one down, or the examiner will assess you on frictional force. Now they are strategic. Instead of saying define the term frictional force, you can define static friction, you can define kinetic friction. They can also require you to state Newton's first law in words. Also, Newton's second law in words. So, as you study, do not just focus on Newton's second law. They can assess you on Newton's first law. They can assess you on Newton's second law. They can assess you on Newton's third law. So, one of the 5 definitions, it will come out to give you 2 marks. And then, ours, it is to be strategic, to say, how do we make sure that we pass now for prelim and final exam? We must set the target. A learner can say, for Newton's laws, I want to get 7 or I want to get 8 marks. How do I get these 8 marks? 2 marks will come from the definition. One of the concepts, they will give me 2 marks. And sometimes they are generous with these definitions, because they can even give me an extra definition to define, which is Newton's law of universal gravitation. So if you find Newton's law of universal gravitation, it means question 2 will have 2 definitions, and 2 plus 2, already you are having 4 out of 7. Then Elena is saying, now that I'm having these 2 marks of the definition, how do I move to 7 marks? The second question from the definition in question 2, it will be a free body diagram. You look at the mark allocation. If it is 3 marks, then it means the number of forces that you must draw, there are 3. If it is 4 marks, the number of forces that you must draw, there are 4. So the mark allocation, it indicates the number of forces that act on that object. So if it's 4 marks, you'll have 2 plus 4, which is 6 marks. Now you can see, wow, I am moving with these Newton's laws. I am moving. Then the next question, it will be a calculation. Most of the time, it is an easy calculation, 3 marks or 4 marks. What do they want from there? Calculate the normal force. If they don't want that, they'll say calculate the kinetic friction. That is 3 marks. If you can get that calculation, you are having 2 plus 4 plus 3. You have done well for Newton's laws. Then the last question, it will be a high order question. 5 marks, 6 marks, or 7 marks. And we are saying to learners, in question 2, when you see 5 marks, 6 marks, or 7 marks, yours is to write F net is equals to ma, and then you substitute from there, because 1 mark will come from the formula, the other marks, they will come from substitution. So when you see 5, 6, 7, it is an indication for you in question 2 to use F net is equals to ma. So Newton's first law, you know when we define it, that an object or a body will remain in its state of rest or motion, or it will move with constant velocity unless a non-zero resultant force acts on it. So it is important to remember that for Newton's first law, F net is equals to 0 unless this F net changes. But if it does not change, the body will remain at rest or move at constant velocity. Newton's second law, we are saying that here F net is equals to ma. So we're looking at the relationship between the acceleration, the net force, and the mass. And remember when we are saying acceleration, because once you have stated the first part, that when a net force acts on an object, the object will accelerate in the direction of the force. Once you are done with that part, the most important is what you do after that dot. You must say acceleration, not the net force. It is acceleration. Because what is it that we are changing? We are changing the acceleration. Acceleration becomes an independent variable. So F net is equals to ma. And then also we can have Newton's second law in terms of momentum. And then Newton's third law, we are saying that when body A exerts a force on body B will exert a force of equal magnitude on body A but in opposite direction. So if F of A on B is 20 newtons, the F of B on A will be 20 newtons but in an opposite direction. So we have summarized question 2. Already a learner is moving with confidence to say, now I can get that target that I've set for myself. I want 7 marks. How do I get 7 marks? 2 marks for the definition, 4 marks for the free body diagram, 3 marks for the easy calculation. F net is equals to ma. Once I see 5 marks, 6 marks, 7 marks, F net is equals to ma, and I substitute. And majority of our marks, they come from writing the correct formula and substituting correctly. Let us not be obsessed with getting the correct answer. Let us be obsessed with writing the correct formula, with writing the correct substitution. Then, I have alluded to you that you will have to perform calculations. But the structure of this question, it is number 1, a definition. Then number 2, a free body diagram. And for us to draw a correct free body diagram, you should be in a position to identify. You should be in a position to identify the forces that act on the object. And also be mindful of these terms: rough surface, smooth surface. What does rough mean? What does smooth mean? So when you talk about rough, already a grade 12 learner must know that it means we're having the presence of frictional force. If it is smooth, then it means we have ignored frictional force, or frictional force is at its minimum level. I have emphasized the issue of mark allocation. A free body diagram, if it's 4 marks, the examiner is indicating to you that the total number of forces that act on the object, they are 4. If the mark allocation is 3 marks, the examiner is indicating to you that the number of forces that act on the object, they are 3. Then the importance of data sheet, it's our friend. An exam guideline and a data sheet, it's our tool to fight. So for us to conquer physics, we must use our tool, which is the exam guideline, which will tell us the scope of the content and the acceptable definitions. And another tool that we must use to get our desired results, it is the data sheet. And you are allowed, learners, to use the data sheet. Copy the formula the way it appears from the data sheet. And then, routine calculation, it's usually 3 marks. The formula, it's a mark. A correct substitution, it has more marks. I want to indicate that. Write the correct formula. Write the correct substitution. We even give you a mnemonic to say, if you forget all of these strategies, remember this word, facade. What does facade mean? Facade, it means for every calculation, write the correct formula. For every calculation, write the correct substitution. For every calculation, get the answer. The answer must be accompanied with units and direction. So remember my middle name, which is facade. Now, our exam guideline is our weapon to make sure that we get all our desired results. Remember we said, when we study Newton's laws, we are looking at 5 definitions. It is what? The normal force. The exam guideline has defined for you the normal force. And the examiner, the marking guideline, must depict or it must show this definition as well. So for us to get 2 marks, let's write the definitions the way they appear from the exam guideline. Let's make sure that we are obsessed with definitions the way they appear from the exam guideline. So the exam guideline is telling us that a normal force is defined as a force or a component which a surface exerts on an object which is in contact with and which is perpendicular to the surface. That's what the exam guideline is saying. Another term that you can be assessed on, it is frictional force. You can see. You see that we are speaking to the exam here. It is remember we said there are 5. It is the frictional force. What is frictional force? It is the force that opposes the motion of the object and which acts parallel to the surface. Frictional force is divided into 2, into static friction, into kinetic frictional force. What is static frictional force? They have defined for you. It is the force that opposes the tendency of motion of a stationary object relative to the surface. What is kinetic friction? It is the force that opposes the motion of a moving object relative to a surface. So all of these definitions, we get them from the exam guideline. Then you'll have to solve problems. These are the easy marks that you can get. For 3 marks, it's either they will say calculate normal force, or they will say calculate static or kinetic friction. But here is my advice here. For that 3 marks calculation, you must know that in everything that you do, you must start with the normal force. You can never calculate kinetic friction without determining a normal force first. So get the normal force. Then you'll have to solve problems. It's either they say kinetic friction, or they say normal force, or they say coefficient. They can use any of the terms. You will be in a position to draw a free body diagram. And I love this. The exam guideline is not saying force diagram. So why are you wasting time studying force diagrams? Because it is telling you that question 2, question 5, question 7, you will be required to draw a free body diagram. And look at the importance of that free body diagram. We find it in question 2, we find it in question 5, we find it in question 7. And if your free body diagram is incorrect, it influences your calculation. Your calculation will also be incorrect. So a wrong free body will give us a wrong calculation. So let's make sure that as we draw our free body diagram, we must make sure that this is where we get our marks. Remember, it's 2 marks of the definition, it is 4 marks of the free body diagram, and then we can continue from there. Newton's first law, remember, it's another definition that I've mentioned to you. You'll be required to state Newton's first law. Newton's second law, you'll be required to state Newton's second law. Newton's third law, you will be required to state Newton's third law. And then these are the scenarios that you can find from your calculation. It's either the examiner will choose a scenario that has a single object. This object can move on a horizontal plane with or without friction. Or this single object can move on an incline with or without friction. Or this object can move vertically up or down. The examiner as well can say, I can opt to use a scenario where we are having 2 objects. And these 2 objects, all the time, they are joined together. And they are joined by a string, meaning that we're having the presence of tension. A scenario that can arise from them is when both the objects, they are on a horizontal surface with or without friction, or both objects that are on an incline with or without friction, or one object on a horizontal plane and the other one on an incline, or both objects, they are hanging vertical. Another question that can arise, it is the one for Newton's third law. What do we look at there? The action-reaction pairs. So we should be in a position to look at the properties of the action-reaction pairs as well. Particularly on the multiple choice, you must know that they can ask you about Newton's third law. Newton's law of universal gravitation. I said, this definition is a bonus definition. Because if you are given this definition, it means for question 2, we are going to have 2 definitions that can give you 4 marks, comfortably so. So, Newton's law of universal gravitation, you must tell us that each body in the universe attracts every other body with a force that is directly proportional to the product of their masses and inversely proportional to the square of distance between their centers. And the formula that we use, F is equals to G, which is a constant, M1, M2 over R squared. And don't confuse this formula with Coulomb's law. Coulomb's law is F is equals to K, Q1, Q2 over R squared. Universal gravitation, F is equals to G, m1 m2 over r squared. Describe the weight and also explain the term weightlessness. So you should be in a position to calculate for the weight. Weight is equal to mg. You should be in a position to calculate for the weight of an object with different values and gravitational acceleration. Okay? Now, let's look at the multiple choice question. Remember we said it is important that we focus on the multiple choice question. So I'm going to give you 2 minutes to respond to this multiple choice question. I am interested in your feedback. We did say that when we deal with a multiple choice, we must read and understand the question carefully. The magnitude of the gravitational force by one body on another is F. When the distance between their centers is doubled, they're telling you the distance is doubled, the magnitude of the gravitational force in terms of F will be. So the first thing that we look at is which content is this question dealing with? It is dealing with universal gravitation. Then we are going to write the formula. F is equals to G m1 m2 over distance squared between their centers. You are told that what will happen to F, they're not telling us about the product of their masses, so we make it 1. If the distance is doubled, because there's a square here, we also put a square, and then our answer will be 1 over 4. So the force will be 1 over 4 times bigger, and the correct answer there is going to be C. So you can see we don't just guess the answer, we work with calculations, we work with principles. And the first thing that you do, eliminate the obviously wrong answers. You'll be left with 2 answers. Make sure that you choose the most correct answer. So the answer is C. Then let's come to this one. It's an activity. Because we are revising, I'm giving you 13 minutes to respond to it, and then we'll have to have a discussion on it. Let's tackle this question. Question 2. A learner constructs a push toy using 2 blocks with masses 1,5 kg and 3 kg respectively. You can see 1,5 and 3 kg. The blocks are connected by massless inextensible cord. This tells you that we are going to have the presence of what? Of tension. The learner then applies a force of 25 newtons at an angle of 30 degrees to the 1,5 block by means of a light rigid rod, causing the toy to move across a flat rough. When you see the word rough, it is also telling you that we are having the presence of frictional force. Horizontal surface as shown in the diagram. The coefficient of kinetic friction between the surface and each block is 0,15. Let's look at the first question. You see, I've predicted this. The first question, it will be a definition. One of the 5 definitions, they will come out exactly as I've mentioned. If they don't say normal force, they'll say frictional force. It can be kinetic or static. If they don't ask those forces, you will define Newton's first law, or Newton's second law, or Newton's third law. So you must make sure that you are confident with these concepts. So the first question, it says state Newton's second law of motion in weights, and we state the definitions the way they appear from the exam guideline. So let's make sure that we state them the way they appear from the exam guideline. When the net force acts on an object, the object will accelerate in the direction of the force. Acceleration is directly proportional to the net force and inversely proportional to the mass of the object. That's how we get 2 marks. 2.2. Calculate the magnitude of the kinetic frictional force on the 3 kg block. You cannot calculate the magnitude of the kinetic friction if you have not yet drawn the free body diagram. So you should be in a position to draw a free body diagram for the 3 kg. You represent 3 kg with a what? With a dot. Then, because we're having a surface, the surface will exert a normal force. Then, we're going to have the force of gravity that is always going downwards. Then, this side, we're having tension. As this object is pulled to the right, we're having frictional force. So these are the forces that act on the 3 kg block. If you look at this free body diagram, it is telling you that the normal force, it is equals to the Fg, but in opposite direction. Normal force is equals to mg, because we can never get the kinetic friction without determining the normal force first. So we are going to use the formula Fk is equals to the coefficient of kinetic friction multiplied by normal force, 1 mark. And then what is the coefficient? You were given 0.15 multiplied by normal force, which is, we did say that the normal force, it is equals to mg. So it is 3 times 9.8. You get a mark for the substitution, and the answer is 4.41 newtons. You get a mark for that. So 3 marks. 1 mark for the formula, 1 mark for the correct substitution, and 1 mark for the answer. 2.3. Draw a free body diagram for the 1.5 kg block. How many marks there? You can see the mark allocation. It is saying 5. It means how many forces must we draw there? You must draw 5 forces. So for the 1.5 kg block, this is the free body diagram. We're having the force of 25 newtons that was exerted at an angle downwards. And then because our surface is horizontal, we'll have a perpendicular force, which is normal force. And we are going to have our force of gravity. Then we are going to have frictional force and tension. How many forces do we have? 1, 2, 3, 4, 5. 5 forces, 5 marks. So if you have drawn 6 forces, then you are going to lose 1 mark. If you have drawn the components, you are going to lose 1 mark. Because the components of a force, they are not a force. A force and components, those are 2 separate things. When they say draw a free body diagram, draw or indicate the force, not the components of the force. I think I've emphasized that. The following question for 3 marks. Calculate the kinetic friction of the 1.5 kg block. Now, for us to calculate the kinetic friction, we did say that our root is normal force. We must pass by normal force. We can never do anything without getting the normal force first. When you look at this free body diagram, it is telling you that if we resort to components here, we are going to have f of y and we are going to have f of x. Then what does this mean? It means that the normal force is equals to f of y plus our weight. What is our f of y? It's f sine theta plus mg. Then you can substitute from there for you to get the normal force. Then our normal force, it will be 25 sine theta plus 1.5 multiplied by 9.8. We multiply it by the coefficient, which is 0.15. So how do you get 3 marks? It's 1 mark for the f of y, 1 mark for mg and 1 mark for the answer. Then the final question, calculate the tension of the cord. It's 5 marks. I said when you see 5 marks, 6 marks, 7 marks, you must say F net is equals to ma. Say F net is equals to ma. So when you see 5 marks, F net is equals to ma. How many objects are we having? 2. So you're going to have F net is equals to ma for 3 kg and F net is equals to ma for 1,5 kg. And for you to have a correct calculation, it is influenced by a free body diagram. So the importance of the free body diagram, I cannot overemphasize it. Let's look at for the 1,5 kg block, F net is equals to ma. You get 1 mark for that. Provided that you have substituted. Write the correct formula and substitute, which will be F of x plus tension plus kinetic friction is equals to ma. Then you must have your direction. If you are saying towards right or where the object is going as a positive direction, then anything that moves away from the positive direction, it becomes negative. So these blocks, they are moving to the right. Any force that moves in an opposite direction, it becomes negative. And how do you know that it moves in an opposite direction? From our free body diagram. So you can see for the 1,5 kg block, F of x is moving to the right, it becomes positive. Plus of the formula, tension is moving on the left, it becomes negative. Plus of the formula, kinetic friction is moving on the left, it becomes negative, is equals to ma. Then what do? You substitute. What is F of x? Is F cos theta. So F of x, it is F cos theta. So this is what we are putting here, which is 25 cos 30 minus tension minus kinetic friction for 1,5 kg, which is 4,08, is equals to the mass is 1,5. We don't know what is acceleration, becomes A. Then 25 cos 30 gives us 17,571 minus tension is equals to 1,5A. So this becomes the equation 1. For the 3 kg block, we are saying any force or every force that doesn't move to the right becomes negative, must have a direction. For 3 kg, if we look at our free body diagram, tension is on the right, kinetic friction is on our left. So tension will be positive plus our kinetic friction will be negative, is equals to 3A. Now for substituting correctly on our right hand side, either by saying 1,5A or by saying is equals to 3A, you get 1 mark. So you can see instead of getting 7, you can get 8. 1 mark for F net is equals to ma, and 1 mark for substituting correctly on the right hand side. Then you can substitute equation 1 in equation 2, solve for acceleration and get 2,925 meters per second squared. Then what do you do once you have acceleration? You substitute that acceleration in one of the equations, either in equation 1 or in equation 2, and solve for tension, and you'll get 13,19 newtons. There is a range. We accept 13,17 newtons to 13,19 newtons. Now we move to question 3, which is vertical projectile motion. And remember, the first thing that we look at is, what is my target? I can get 7 marks from VPM without sweating. How do I get 7 marks from VPM? 2 marks will come from a definition. Which definition must I be mindful of? It's either they say free fall or they say projectile. So you must know, when we talk about free fall, it is the motion under the influence of gravitational force only. If we talk about projectile, an object has been given an initial velocity and then it moves under the influence of gravitational force only. So free fall is the motion. Projectile, an object has been given an initial velocity. So the object can be thrown, the object can be launched. So now as a learner, you say, okay, I can get these 2 marks, the definition. The first calculation is the easiest calculation. It's 3 marks or 4 marks. You can get total there. Just take out the information from the scenario, choose the correct formula, write the correct answer with the correct units, and have a direction. Remember facade. So when we deal with VPM, we are saying, number 1, understand the statement. Then from there, what must you do? Choose your direction. If you say let up be positive, then your A will always be minus 9,8. If you are saying downwards as positive, then your A becomes positive 9,8. Then from there, you'll have your data. Your data will influence the correct formula. After writing the correct formula, write the correct substitution. Because we are saying, for you to get maximum marks, write the correct formula, write the correct substitution. So read the scenario and understand it. Choose your direction. And then you must look at these words sometimes. How long we're looking about the time. How far we're looking at the distance. How high we're looking at change in y. How fast we're looking at the time. Consider the motion of the object between 2 points. Look at the mark allocation. And make sure that you write the correct formula and the correct substitution. The exam guideline is our weapon, remember. We're using 2 weapons here. We must have the exam guideline in mind and the data sheet. Projectile, an object has been given an initial velocity. Free fall, it is the motion. So these are the 2 definitions that you can find. And then from there, you'll have to use the equations of the motion to determine the position, velocity, displacement of a projectile at any given time. And also the last question, you'll be required to draw the graph. Position versus time graph, velocity versus time graph, acceleration versus time graph. And you must be mindful that a question may have a bouncing ball. And also it might have a ball that is thrown vertically upwards or a ball that is thrown vertically downwards. Here is a multiple choice question. I'm giving you 2 minutes to respond to it. Let's look at this multiple choice. A stone is thrown vertically upwards, so it's a projectile. An object has been given an initial velocity. And then it returns to the thrower's hand after a while. Which one of the following position, this is the keyword, versus time graph represents the motion? The motion was thrown from this position. It went up and it came down to the very same position. So the correct answer there, before you choose it, you look at the obviously wrong answer. An obviously wrong answer, it can be B and D. Then it means you are left with these 2 options, A or C. A, it tells us that this object has been thrown up, but it fell down to the ground with a certain final velocity. So that is why A is incorrect. C is the most correct answer. So that is how we choose a correct answer. We don't just guess and say because my grandmother's name is Dorothy, therefore the answer is D. No, we interrogate each aspect. Let's go to question 4. But before we move to question 4, let's do this question. Now, a man throws ball A downwards with a speed of 2 meters per second from the edge of a window 45 meters above a dam of water. 1 second later, he throws a second ball, B, downwards and observes that both balls strike the surface of water in the dam at the same time. Ignore air friction for 3 marks. Calculate the speed at which ball A hits the surface of the water. It's 3 marks. The ball was thrown with the speed. So this is the initial velocity. So you must have your data. Choose your direction. Let up be positive. Let up be negative. Then, an option that a learner can choose is this one. If we are saying up as positive, Vf squared is equal to Vi squared plus 2a change in y. We want the speed as it hits the water, which is the final velocity. So Vf squared is equal to Vi squared. Remember, this ball was thrown down. So it means the initial velocity becomes minus 2. Don't forget to square it. Plus 2, our A, because set up be positive, A is always going down. So it becomes minus 9,8. And the displacement, it becomes 45, which is negative 45. And then our Vf will be 29,76 meters per second. So 1 mark for the formula, 1 mark for substitution, and 1 mark for the answer. 3.1.2, the time it takes for the ball B to hit the surface. Then we can have an option here. This option, we can first look at the time it takes to reach maximum height. So our Vf already we know it is 29,76. Our Vi, it is minus 2 plus minus 9,8 change in time. So the instant time there for ball A is 2,83. And then they are saying after 1 second. So that is why you must say 2,83 minus 1, which will give you 1,83 seconds. 3.1.3, calculate the initial velocity. When they say initial velocity, your answer must have the direction, facade. So, if you choose for ball B, our change in y is minus 45. So the formula there would be change in y is equal to Vi change in time plus 1 over 2a change in time squared. Our change in y is minus 45 is equal to Vi. Our time is 1,83 plus 1 over 2. Our a is minus 9,8 multiplied by time, which is 1,83 squared. And then the initial velocity will be 15,62 meters per second squared downwards. So that will be our initial velocity, 16,62 meters per second squared downwards. Then the graph, you must have the graph for ball A. You know, for ball A, it was thrown vertically downwards. So when you throw something vertically downwards, the velocity increases. And it do not move from 0. We do not drop, we threw. So the initial velocity is 2. The ball started from 2. And then it went down and hit the ground with a certain velocity. Then ball B, after 1 second, it was again thrown downwards. As we throw down ball B, it will increase in velocity. But what is important, remember the person observed that all of them, they hit the water at the same time.